This question involves a region in the xy plane. Since the inequality is less than or equal to, the region will be defined by everything that is left and below the line 5x plus 6y equals 30. That line can be put into the form y equals mx plus b by subtracting 5x from both sides of the equation and dividing by 6. That gives us this equation. On this line, when x equals 0, y is 5. 5 is the y-intercept. The line slopes down to the right at a moderate angle and crosses the x-axis when y is 0, where x equals 6. Indeed, while the line format y equals mx plus b is useful, the format given to us in the question does allow us to see the x and y intercepts fairly easily. We can go ahead and sketch this line on our noteboard. Let's go on to the data statements, evaluating them first separately. Statement 1 describes a similar but different line than the border of region R. It can quickly be judged insufficient on the grounds that it is aligned with a different slope than the boundary line. You might react by asking, wait a minute, the question said RS was a point. Why are we talking about a line of R and S then? We are talking about a line because statement 1 has not uniquely defined R and S for us. RS is indeed a point, but on the basis of this equation in statement 1, we can only narrow down the field of possibilities. A line is a collection of points, and the line here describes all the possible locations of R, S. If this line lies either wholly inside or wholly outside region R, then we will be able to answer the question of whether RS is inside the region for all possible cases. On the other hand, if the line of possible locations is partly inside and partly outside region R, then we will not be able to answer the question definitively. This latter possibility is, in fact, the reality. The line 6r plus 5s equals 30 has a y-intercept of 6 and an x-intercept of 5. The values are switched from the intercepts of the border of region R. As we can sketch, the two lines cross like an elongated diagonal letter X. Indeed, the only way a line would not cross the border of region R would be for that line to be parallel to that border, since any pair of non-parallel lines will cross eventually. By this train of thought, you could compute the slope of this line and identify it as different, using the intercepts and the fact that the slope is rise over run. Statement 1 is insufficient. Statement 2 describes the range of possibilities for the point R, S with two boundaries. Since each boundary is parallel to an axis, Statement 2 describes a box-like corner boundary that includes everything to the left and down. It looks something like this. The upper right triangle is permitted by Statement 2 as it's inside the box, but it's outside of region R. Meanwhile, the region described by Statement 2 also includes plenty of points inside region R. Once again, based on the data in this statement, the point could be either inside or outside of region R, so we are unable to answer the question definitively. Statement 2 is insufficient. We must combine the statements. When both statements are true, the field of possibilities is significantly reduced. The point must now be on the line described in Statement 1 and within the rectangular boundary, like so. The remaining line segment still has a portion inside of region R and outside of region R, so the statements together are insufficient. We can double check and make sure we haven't drawn incorrectly by choosing cases. For example, the point 5, 0 is on the line in Statement 1, and it satisfies the condition that R is less than or equal to 6. That point is inside region R. It's a little trickier to come up with a point that is in the short segment above region R. Since S is less than or equal to 5, we can choose a value of S that is near 5, but less, say 4 4/5. By plugging that into the equation in Statement 1, we see that R is 1. This point is on the line segment. And if we plug R equals 1 into the boundary line, then we get 4 1/6 for the value of y. Since 4 1/6 is less than 4 4/5, the possible S value that the possible RS value that we are looking at is on the line described in statement 1, it's inside the boundary described by statement 2, and it's outside, above, the region R. That's proof that there is a point that's outside the region as well. We still have an answer that's yes and no, so together the statements are insufficient. The correct answer is E.